Today we are talking about comparing and ordering rational numbers. Remember that any number that can be written as a fraction or ratio is a rational number. Okay, we're going to be looking at comparing rational numbers. So we're going to replace the box with the less than, greater than, or equal sign to make 3/5 and 3/7 a true sentence. So method one, if you are comparing fractions, we could write the fractions with the same denominator. So the first thing we would do is find the least common denominator. 5 and 7, the least common denominator would be 35. So I have to multiply both the numerator and the denominator by 7 to make sure that I have the same common denominator. And then I would multiply this by 5, and I get 15/35. So now I'm actually going to compare these. I have 21/35 and 15/35. Since 21 is greater than 15, 21/35 would be greater than 15/35. So 3/5 is greater than 3/7. That is one way that you can compare fractions. Another way is to cross multiply and compare those products. So I'm going to take the original problem, 3/5 and 3/7. You may have heard someone call it the butterfly method, but what we do is we cross multiply and we go from the denominator up to the numerator. So 5 times 3 is 15, and then I do the same thing here. 7 times 3 is 21. 21 is greater than 15. So again, 3/5 is greater than 3/7. Now let's look at some more examples. This time we're going to throw in some negatives. So we need to talk about comparing negative fractions. I would like for you to try number 1 on your own, and then let's look at number 2. So you might want to pause, try number 1, and we will check this problem in class. Okay, number 2 is a negative 9/16 compared to a negative 3/4. Now, we could do cross multiplication and compare that way, or we could find a common denominator. I'd like to find a common denominator on this one. So my common denominator would be 16. So 9/16, negative 9/16 remains the same, and then I would multiply negative 3/4 by 4/4 to get a negative 12/16. Now, with negatives, we have to remember that negatives are a little bit different when we're comparing. So I'm going to draw a little number line here. And let's look at negatives. If I have a -1, -2, -3, and I'm comparing those numbers, the greater number is going to be the one that's closer to 0. So I'm going to make a little note of that the greater number it is closest to 0 when we're talking about negatives, okay? So a -1 is going to be greater than a -2 because it's closer to the positives, okay? So -9, even though it may seem like it's smaller because when you're comparing 9 and 12, a -9 is actually going to be greater because it is closer to 0. If you have any questions about that, make sure that you ask those questions in class tomorrow. So a negative 9/16 is going to be greater than a negative 3/4. Now let's look at number 3. A negative 1 4/9 compared to a negative 1 2/5. I would like for you to pause this and try this problem on your own, and then we'll check it in just a second. Okay, hopefully you had a chance to try this one out. So what we're going to do is we're going to leave the whole number, the negative ones, the same. And we're going to just look at our fractions because -1 and -1 are the same. So I'm going to make 4/9 and 2/5 have a common denominator. And our common denominator is 45. So I get 20/45 and 18/45. Okay, so I have a -1 and 20/45 and a -1 and 18/45. So again, I need to think about the fact that these are negative numbers and I want the one that's closer to 0. So if I'm looking at 20/45 and 18/45, a -18 is going to be closer to 0. It's going to be closer to getting to the positives. So this is going to be my greater number. Okay, number 4. Now we're comparing decimals. So when you're looking at decimals, you want to look at each place value. So we look at the tenths place. So this is our tenths place, and we look at the other tenths place. Now these are negative numbers. So remember, we're looking for the number that would be closer to 0, getting closer to the positives. If these were positive, then 0.8 or 8/10 would be greater. But because these are negatives, 0.78 and -0.78 is going to be our greater number. Okay, now we're going to compare fractions and decimals by using decimals, by converting the fraction to a decimal. So we want to convert 7/11 to a decimal. So we would divide 7 by 11. So 11 goes into 70 6 times. And we have a remainder of 4. We bring down a 0, and we have 40. 11 goes into 40 3 times. And so it looks like what's going to happen is we're going to have a repeating decimal that goes on and on. So we would have 63 hundredths repeating. So when I compare this, these are both positive decimals. So I'm going to look at my tenths place first, and 7/10 is our greater number. So 7/10 is going to be greater than 7/11. Okay, 1/3. We know that 1/3 is 3 repeating, 3/10 repeating. So when I work that out, that means I would have 3 on and on and on. When I compare that to 3/10, obviously the tenths place is the same. However, when I look at the hundredths place, this would be 0 and this is 3. So 1/3 is going to be greater than 3/10 because the hundredths place has a 3 and the hundredth place here has a 0. I would like for you to try number 2 on your own. That problem will be checked in class. Okay, number 3. Here we have 2 5/12 and 2 42 hundredths. So I want to convert 5/12 to a decimal so I can compare my decimals. So I'm going to ignore the 2's for now because they're equal, and I'm just going to compare the fraction part. So I'm going to divide 5 by 12. 12 goes into 50 4 times. Add a 0, bring it down. 12 goes into 20 1 time. And I can actually stop here because I can already see that I don't need to go any further because I have 2 41 hundredths compared to 2 42 hundredths. So 2 42 hundredths would be greater than 2 5/12. Now the last thing we want to do is order rational numbers. So we're going to have to write each fraction as a decimal. Now you could convert the decimals to fractions, however, then you might have to find common denominators and it would be one extra step. So we want to convert the fractions to decimals because many of these fractions you may know by heart. So 1 4/5, I know that 4 divided by 5 is 0.8, so this is 1 8/10. I know that 1/4 is 2500, so I have 2 2500. 3/5 is 6/10, so 2.6. And then the rest are already decimals. So now we need to compare. So I'm actually going to look at the ones first because we're going from least to greatest. So I'm going to go ahead and look at all of the ones. So I have 1.1 is my least. Please be sure when you are ordering these that you put them back into their original format. So I have 1.1, I'll X that out. My next number is 1 3/10 repeating. And then I have 1.8. I need to put that back in its original format. So I'm going to say 1 4/5. And then the last one is 1.87 or 1 8700. Now I need to look at my twos. Okay, so my least 2 is going to be 2 2/10 repeating because this tens place is a 7, this is a 2.25, this would be 2.222, so this is going to be my least. The next is 2.25, which I need to put in its original format, which is 2 1/4. The next is 2.32. Then we have 2.6 because that's going to be greater than 2.7. We need to put that back in its original format, 2 3/5. And then our last is 2.7. So all we did was we put them all in the same format so that it would be easier to compare. And then we make sure and put them back in their original format. So the last problem is ordering lengths from least to greatest. So again, you're going to put them all in the same format and then write them in order from least to greatest. This problem will be checked in class tomorrow.